Oh, hello. I'm Noah.
And I'm Gianna.
And this is an introduction to acids and bases. After this quick commercial break, we'll get back to you on the Arrhenius concept.
Get ready to be educated. Seriously? Don't ever talk to me again.
Oh, and we're back. Did you know that acids produce hydrogen ions in aqueous solutions?
And did you know that bases produce hydroxide ions in aqueous solutions?
Did you know that superior acids are proton donors?
And bases are proton acceptors.
As we can all see here, I think acids kind of went out over the week because the bases.
But bases are charitable and they're electron donors.
Hello, Gianna and I are here to show you an example of an acid and base reaction. Here we have delicious common household vinegar that you can find in one of your cabinets. And here we have sodium bicarbonate. You may know that as baking soda. We're going to mix these two and see what happens. It'll make for a pretty basic reaction. The reaction between these two forms carbon dioxide gas, which escapes in the form of bubbles, and after it overflows, a dilute sodium acetate solution remains.
The Arrhenius concept of acids and bases. A concept postulation that acids produce hydrogen ions in an aqueous solution, whereas bases produce hydroxide ions. Examples of this are hydrochloric acid and Arrhenius acid. An Arrhenius acid is a substance that dissociates in water to form hydrogen ions. In other words, an acid increases the concentration of hydrogen ions in an aqueous solution. An Arrhenius base is a substance that dissociates in water to form hydroxide ions. In other words, a base increases the concentration of hydroxide ions in an aqueous solution.
The Bromford-Lowry model of acids and bases is the general reaction that occurs when an acid is dissolved in water. It can be best represented as an acid donating a proton to a water molecule to form a new acid and a new base. An acid is able to lose or donate a proton while a base has the ability to gain or accept a proton. Here are some examples.
Conjugate bases are formed by the removal of a proton from an acid. It is what remains after the proton is lost. Conjugate acids are formed when a proton is added to a base.
Well, let's take a moment to talk about acid strength. A strong acid is one that completely dissociates to produce hydrogen ions in the conjugate bases. A weak acid is one that dissociates only to a slight extent in an aqueous solution. Well, wasn't that fun? Well, thank you for tuning in. This is Noah signing off.
With Gianna.
Chemistry.